Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the single pattern that separates an agent, that's a great demo from an agent you can actually ship. And it's basically a pause button.
Set the stakes for me. Why does the pause button matter so much?
Because the agents that survive contact with production almost never run end-to-end without supervision. The instant the LLM is about to do something with consequences, send an email, file a ticket, run ASQL delete, charge a card, you want a human in the loop. Someone who can review, approve, or correct the planned action before it actually happens. The lesson has a lovely forward name for the shape. LLM proposes, human disposes.
And LangGraph has a built-in mechanism for this. Interrupts. How does it work mechanically?
To knobs you set when you compile the graph. Interrupt before, with a list of node names. Pause just before any of those run. And its mirror, interrupt after. Pause just after a node finishes. So you say interrupt before the send node. When invoke reaches that point, it stops dead and returns to you. And here's the key word. The graph is paused, not finished. The state is sitting safely in storage.
Wait. How does it survive the pause? If my server restarts while it's waiting on a human, isn't the whole in-flight state gone?
That's the crucial dependency. And it's why this lesson builds on the previous one. It works because of the checkpointer. When the graph pauses, it writes the full current state to durable storage. So the process can sleep, the pod can restart, a human can take 3 days, and the state is on disk the whole time. That's the difference between a flimsy pause and a real one.
Okay, so it's paused on disk. How do I wake it back up?
One line, and it's almost too cute. You call invoke again, but instead of passing input, you pass none. Literally nothing. That none is the signal. No new input, just resume from where you stopped. LangGraph reads the saved state, picks up at the exact interrupt point, runs the next node, and carries on. Most people expect a .resume method. It's just invoke with none.
Make it concrete. Give me the canonical example end-to-end.
An email drafting agent. 3 nodes. Draft. The LLM writes the email from your intent. Review. A human looks, maybe edits. Send actually fires it off through an API. And you set interrupt before on send, so you invoke it. The graph runs draft, then stops cold right before send, because send is in the interrupt list. The finished draft is sitting in the state, but nothing irreversible has happened. Your send flag is still false.
And how do the human's edits get back into the graph? I can't just hand it a new draft mid-flight, can I?
You can. And this is the second piece. If the human tweaks the draft, you call update state with their change first. It merges the edit into the saved state. Say they change circle back to follow up. Then you call invoke with none. The graph resumes at send, sends the now edited draft, and the send flag finally flips true. Update the state, then resume.
Here's what I find genuinely elegant. The draft and send functions never mention the human at all, do they?
And that's the deep point. You nailed it. The graph code didn't have to know about the human. None of the node functions contain any wait for approval logic. The interrupt is a runtime concern, not a node concern. You wrote a plain 3-step graph, and the safety gate got bolted on at compile time, completely outside the business logic. That separation is the whole beauty of it.
So how does the app even know it's paused versus done? Both come back from invoke.
You inspect the state snapshot. There's a next field, the node it would run next. If that's non-empty, you paused. Show the human the UI. If it's empty, the graph genuinely finished. So next is non-empty literally means we stopped. Render the approval screen. That's your signal to the front end.
And this approve or edit thing? Is that the only shape or is the mechanism more general?
Much more general. It's one primitive, many patterns. Approve, reject, edit, regenerate. Reject updates the state with guidance and reruns the draft node. Regenerate clears the draft and reruns it. Tool authorization. The LLM proposes a tool call. The graph pauses before any high-risk tool. The human authorizes the specific call. Clarifying questions. The agent asks something, pauses. The user answers via update state, resume. Even multi-stage approval, different reviewers at different nodes. A draft reviewer here, a legal reviewer there. All the same 3 primitives.
Let me get the white matters in one line because this is the production lesson. Why is this non-negotiable?
Because a fully autonomous agent is a great demo and a risk to ship. Almost every successful production agent has at least one of these pauses. Before sending, before writing to the database, before charging the card. It's so consistent, it's nearly a rule. If the action has consequences, gate it on human approval. Yes, you pay latency. But the alternative is the agent sending 4,000 wrong emails overnight.
Now I want the gotchas because there are always 2. What's the bug everyone hits first?
The classic one. Forgetting the checkpointer. Interrupts only work with persisted state. If you forget to pass the checkpointer at compile time, the graph hits the interrupt and just raises an error. There's nothing to pause into and nothing to resume from. Always pair them. Interrupts and checkpointer come as a set.
And the subtler, scarier one?
The security one, and it's nasty. The moment the human's edits come from a web client, every field flowing back into a tool call is now untested input. Picture it. The agent proposes send email to a customer address. The UI lets the operator edit the body. Fine, but a buggy form also lets them edit the recipient. Suddenly someone can redirect the email anywhere. So you constrain what update state is allowed to change for a given thread, or you validate the diff server side before you reinvoke. Don't trust pause state just because a human touched it.
So the one sentence to walk away with:
Interrupt before plus a checkpointer lets the graph freeze right before anything irreversible. Hand the decision to a human and resume with invoke none. And that single pause is what makes an agent safe enough to actually ship.
propose, then dispose. That's the Datarekha audio guide. See you in the next one.